Yesterday my life was filled with sadness. I had little hope of ever finding gladness. All my roads were closed and thought would never more.
Okay, at long last we're going to return to section 7.5 and complete that section. When we did it before, we talked about application of quadratic functions. Now we're going to talk about application of quadratic equations. Okay, just looking at equations today. And of course I'm going to use the Pre-Calculus 11 video, so I'll go to that video in just a second. But what we're going to be doing is we're going to be setting up some quadratic equations that are going to solve some word problems. And I guess the main question I have is, how are you going to do that? How are you going to solve these quadratic equations? Basically, you're going to set up a quadratic equation, make it equal to 0, and then you're going to have a choice of how to solve it. You might want to graph it, and if you're the sort of person who wants to solve by graphing, good for you. I'm not like you. I would not want to do that. It's too much work. You might want to try to factor it. That's actually my preference. So I always try to factor, but you can't always do it. So what other ways do we have to solve? You could complete the square, which is not a bad idea, but I imagine that'll almost never be done by anyone as well, because if you can't factor, I bet the way most of you will do this is you'll use the quadratic formula. X equals negative b, right? So those are pretty much the ways that you can solve these equations. Sometimes there'll be the square root method, but that's only when there's no b value, and that doesn't happen all that often. Okay, anyway, let's solve some questions. Two numbers have a sum of 20 and a product of 84. Use a quadratic equation to determine the numbers. Alright, well, there's two numbers, so if you know nothing else, you could write down first number, second number. And guess what we're going to call the first number? Well, anything you want, A, B, C, D, but I'll call it X. They have a sum of 20. Okay, here's that thing that keeps coming up over and over and over. I'm hoping that you're starting to get the idea here. If two numbers sum to 20, they add up to 20, and one's X, what's the other one? 20 minus X. Should I very quickly go through Y again? If two numbers add to 20 and one's 5, what's the other one? 15. How do you do that? 20 minus 5. Two numbers add to 20 and one's 7, what's the other one? 13. How do you get that? 20 minus 7. If two numbers add to 20 and one's X, what's the other one? 20 minus X. Okay, very important, comes up all the time, so make sure you understand how that works. Okay, so we have our two numbers, X and 20 minus X, and now it tells us that the product of those two numbers is 84. In other words, multiplying the first number by the second number equals 84. Okay, let's expand here. Distributive property, mountains. So 20x minus x squared equals 84. So that's a quadratic equation, but we want it to be equal to 0. So should we move this one term over to the left? No. Why not? Because we want the leading coefficient, we want that x squared to be a positive amount. So why don't we move these two things to the right? So we get 0 equals negative x squared moves over and becomes x squared, 20x moves over and becomes negative 20x, and we still have a plus 84. Okay, you're good to go. You could graph if you want. You could try factoring, completing the square, quadratic formula. I'm going to try factoring in this one because what I'm looking for is two numbers that multiply to 84 and add to 20. Now I know that's hard, and if you can't do it, you're welcome to use the quadratic formula. It will work, but I think we can do it. So 84, well, that could be 1 times 84, or 2 times 42, or 3 times 28. That actually works. I like that. 3 times 28 is 84. 4 times 21. Can't do 5. 6 times 14. Hey, 6 times 14 is absolutely the answer right there. So I can make this. This is just simple trinomial, not Bobby Bridge. Big number goes first. Second number goes second. Bring the negative down. A negative times a negative equals a positive. So x could be 14 or x could be 6. So the first number is x. In other words, if we're going with x equals 14, then the first number equals 14 and the second number equals 20 minus 14, which is 6. In this case, if x was 6, the first number would be 6, and the second number would be 20 minus 6, which is 14. So we get the same thing in both cases. We get that the two numbers are 6 and 14. But you have to be careful. In a lot of these questions, if you get two solutions, it means there'll actually be two sets of numbers. So make sure you check them both out and see what your answer is. Okay, a rectangular garden has dimensions 3 by 4 meters. Well, I know already I'm going to be doing some sketching here, so let's sketch this. Have a garden, and that's pretty square-like, but oh well. We'll call this 3, and we'll call this 4 here. Why did I not write the numbers on the inside? Because there's a path built around it. So here's my path. It goes around the outside like this. The area of the garden and the path is 6 times as great as the area of the garden. What's the width of the path? Okay, so a few things. One, we're going to assume that the width is the same all the way around. So whatever this distance is here is the same as this distance here, it's the same as this distance here, it's the same as this distance here. And that's actually what we want to find. We want to find what's the width. So guess what we're going to call these distances? X, and it's the same here, X, and the same here, X, and it's the same here, X. Okay, it talks about the area of the garden. Well, we can figure out the area of the garden. The area of the garden is this inside part here. How much is the area of the garden? 3 times 4, which is 12. So area of garden equals 12. You probably don't need to write this down, but just to be clear, the area of this yellow part here is 12. And it says the area of the garden and the path together. So the area of the whole thing, I'll put area of green rectangle, is 6 times as much. So it's 6 times as much as this. 6 times 12 equals 72. So we know the whole area of this green rectangle is 72. Now, how far is it from here to here? Well, you know from here to here is how much? 4. But you also know from here to here, this is x from here to here, this is 4 from there to there, and this is x from there to there. So total, this dimension here is 4 plus 2x. Very similar to going this dimension, I'll do it in red. This dimension here, from here to here, is how much? Same as that, so it should be 3. This is x, and this is x. So the other dimension is 3 plus 2x. And if we're interested in the area of the whole green square, we multiply this dimension, 4 plus 2x, times this dimension, 3 plus 2x, and we get the 6 times as much as 12, which is 72. We get 72. Okay, let's expand. 4 times 3 is 12. 4 times 2x is 8x. 2x times 3 is 6x. 2x times 2x is 4x squared. And we have 72. Let's put this in descending order. So we'll put 4x squared first. Combine the 8x and the 6x to get 14x, and then we get 12, but we're going to bring the 72 over and do take away 72, so we're going to get negative 60 equals 0. Alright, we could factor out a 2. We should take out a grayscale. Oh yeah, I'm going to try factoring again. You could use the quadratic formula, but I'm going to try factoring, so I'm going to factor out a 2 and get 2x squared plus 7x minus 30 equals 0. Okay, now I could divide both sides by 2 and just cancel out this 2, right? So the 2 we don't even have to worry about. So we're interested in factoring that left-hand side, and unfortunately we have a 2 out front. What kind of, this 2 right here, right? What kind of factoring are we going to have to do? Bobby Bridge. So we're looking for two numbers that multiply to 60 and subtract to 7. Okay, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and that's all of them. Subtract to 7. There they are, right there. So decompose 2x squared plus 12x minus 5x will give us that 7x. Minus 30 equals 0. Pair them up. Going pretty quick here, but you should know how to factor this. 2x, and we're left with x plus 6. Bring down that negative sign, and greatest common factor is 5. Careful, it's x plus 6, because negative 5 times positive 6 equals negative 30. Great, we got the same thing. Factor out the x plus 6, and we're left with 2x minus 5 equals 0. So this one, x equals negative 6, and we're going to reject that. Why? Because we're talking about lengths. You can't have a negative length? That makes no sense. So this is not one of the answers. Solves the quadratic equation, but it does not solve the real world example that we're talking about. Okay, that's solved the first factor. What solves this factor? Kind of hard. So let's write out 2x minus 5 equals 0 and actually solve it. Add 5 to both sides. I get 2x equals 5. Divide by 2. I get x equals 5 over 2, or 2.5. Okay, so we found x is 2.5. What's x? X was the width of the path, and that's what we wanted to know. So this is our answer. 2.5, what is it, centimeters, meter? Well, not centimeters, I guess, meters. Be pretty thin path if it was centimeters. 2.5 meters. When the square of a number is added to the number, the sum is 3. Oh, there's only one number. So call the number x. X equals the number. So when the square of a number, well, the square of a number is x squared, is added to the number, the same number, x, the sum, adding them together gives a sum of 3. Oh wow, this is pretty quick. So let's get it equal to 0. And let's try factoring. Two numbers that multiply to 3 and subtract to 1. Well, the only numbers that multiply to 3 are 1 and 3. Do those subtract to 1? No, they don't. We cannot factor. So you could either complete the square, or imagine what most of us will do is we'll use the quadratic formula. X equals negative b, so that'd be negative 1, plus or minus the square root of b squared, so that's 1 squared, minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a, which is 1. So x equals negative 1 plus or minus the square root of 1. 4 times 1 is 4, times negative 3 is negative 12, sorry. So you get 1, take away negative 12, all over 2. So x equals negative 1 plus or minus the square root of 13 divided by 2. Can we simplify this? Can you simplify root 13? No, you can't. This is your answer right here. How many answers is there? 2. Negative 1 plus root 13 over 2 and negative 1 minus root 13 over 2. Last question. A truck was traveling at 23 meters per second. It decelerated for 15 seconds. The distance traveled by the truck, d meters, during this time is given by the formula. So this is really what you're going to be using, is this right here, where t is the time, and it already tells us that d is the distance. So the first question is, how far did the truck travel in 1 second? 1 second, we know this, and this is a time. That was a pretty silly question, I know. Okay, so in other words, we know the time. We can plug it in here, and we can plug it in here and solve, and we'll have our answer. We'll know how far the truck traveled in 1 second. Alright, so d equals 23 times 1 minus 0.6, 1 squared, and that'll give us the distance. I'm glad it's 1. It makes it quite easy, doesn't it? Be harder if it was 1.2 or something. 23 times 1 is 23. 1 squared is still 1, times 0.6 is still 0.6. So the distance it's traveled in 1 second is 23 take away 0.6, which is 22.04 meters. That's how far it went. Alright, didn't have to do any real solving, like no quadratic formula or anything in that one. It's the second part of the question that you're going to have to do something like that. How long did it take the truck to travel 60 meters? Distance or time? Distance, so you're going to put it in here. So you get 60 equals 23t minus 0.6 t squared. Oh boy, that looks complicated. But you can still use the same sort of methods. You could try factoring it. You could try completing the square, but once again, you'll probably use the quadratic formula. So let's make it in proper form. We have to have the leading coefficient positive, so we'll move it over. We get 0.6 t squared, then move the 23t over, minus 23t plus 60 equals 0. And quadratic formula time. Negative b, that would be negative 23, so it's 23 plus or minus the square root of b squared, so that's negative 23 squared, minus 4 times a, which is 0.6, times c, which is 60, all over 2a, which is 0.6. Oh my, we're going to have to get the calculator going here. So we get 23 plus or minus the square root of, I don't know what 23 squared is, 529 minus 144. All over 2 times 0.6 is 1.2. Okay, okay, sure. 23 plus or minus the square root 385 over 1.2. Now, in this question, this is the sort of question I'd ask you to give me the answer as a decimal. So let's do that. Let's keep going here. 23 plus or minus about 19.6. We'll just go to one decimal. So 23 plus or minus 19.6 over 1.2. So we have two answers. One's 23 plus 19.6 over 1.2, and one's 23 minus 19.6 over 1.2. Let's keep going with both of those and see if they both make sense or not. Doesn't seem at first. How can there be two times that the thing's at the same speed? Doesn't seem to make sense. So let's do the top one. 35.5. 35.5, and the other one would be 2.83, or I guess just 2.8. Okay, what were we finding here? We were finding time. So this is 35.5 seconds or 2.8 seconds. Are they both good? Are they both correct? Let's read the question again. A truck was traveling at 23 meters per second. It decelerated for 15 seconds. Okay, it makes no sense for it to decelerate for 15 seconds but take 35.5 seconds to travel 60 meters. So in other words, you are going to say no way to this one, and this is our answer right there. I mean, just thinking about it, a truck decelerating. Imagine some guy jamming on his brakes and it taking 35.5 seconds for the truck to stop. It's actually quite humorous. 2.8 sounds much more likely. Slam on the brakes, 1001, 1002, 1000, you're stopped. That's about how long it would take. There you go, you got our answer. Alright, hopefully you get the sense. I know they're somewhat difficult to figure out what the equations are, but once you have the equations, you know how to solve them. You're going to solve them using these wonderful methods here, especially factoring and quadratic formula.
I wanna say